Hello. Good afternoon, everyone. So, welcome to my session. I'll be giving a session on introduction to Istio. So, little introduction about myself. My name is Amish Shah. I am a senior DevOps consultant at NASDAQ. So, before we jump into the session, let's go through some knowledge etiquettes. Please join session within the time, 5 minutes prior to the start time. Provide some constructive feedback at the end of the session. This will help the presenter to improve its next session. Keep your devices in silent mode and feel free to move out if in case you have any emergency, and avoid any unwanted chit-chat during the session. So let's jump into the session. So in today's session, we'll be discussing what is Istio, and we'll have a little demo, by deploying an sample application, book info application on Istio. So in this session, we will discuss what is Istio, why we are using it. And we will also go through the architecture of the Istio, discuss the key features. We'll have some use cases where we can use Istio, and at last we'll end our session with a demo. So let's jump into this. So first, what is Istio? So Istio is basically an open source service mesh that provides the way to control how microservices share their data among each other. The main purpose of this is to enhance the security, observability, and management of the microservices by adding an additional infrastructure layer between the services. So nowadays we are deploying everything using microservices. So for better security, observability, and management, we are introducing Istio. So the key feature is traffic management. So it provides with intelligent routing and load balancing. Security. So service-to-service communication and communication authentication, encryption, and authorization is also provided by this. Observability. So in observability, monitoring, logging, and tracing. So Istio comes with an inbuilt Kali dashboard. So it provides better observability and tracing of the request that we send to the our application. So first, in the first line it said it's an open source service mesh. So what is a service mesh? Let's first discuss that. So service mesh is basically an infrastructure layer that manages the communication between microservices. So lot of microservices they can communicate when they are in a service mesh. They can communicate within among themselves. So for this, we don't have to do any change in the business logic. So that's why it's saying it's that manages the communication between microservices in an application without any change in the business logic. So there is a component in a service mesh called proxy that handles all this kind of activities. So it provides us with the traffic management, security, and observability that we just discussed, but in the Istio. So traffic manager, it controls how the request is routed. Security, secure our communication with features like mutual TLS, and controls metrics, logs, and tracing of the traces for the monitoring. So it gives us better observability feature. Benefit is that it provides reliability and security. Improves the visibility into service abstraction, so we can see how our services are interacting with other services. Uh, and service mesh basically simplifies the management of the complex microservice architecture. So why we want to use, what is the need that we are introducing a new tool called Istio? So earlier when we are having monolith architecture, then we move to the microservice architecture. So nowadays every application has thousands of microservices, and they come with very complex, much higher complexities. So managing the multiple services increases the complexity of deployment and operation. It increases the network latency between the communication of the services. So that introduces a point of failure. In the security aspect, so each service should need to authenticate individually with other services to get authenticated, authorized. So it increases the overall security management effort. And with the monitoring and debugging view, so the traditional monitoring tools is not sufficient for this. So it requires more advanced solution for observability. So Istio provides us with the solution. So it simplifies the operation with an uniform management approach. It ensures the reliable communication with timeout, retries, and circuit breakers. It provides better security with mutual TLS authentication and authorization for secure communication, and it enhances our observability with a detailed metrics, logs, and distributed tracing. So let's move and discuss the architecture of the Istio. So this is a basic architecture diagram. We'll elaborate, fill the gaps here, but this is the simple one. So Istio consists of two. One is data plane, another is control plane. So data plane is basically deployed on the pods. It's basically having a major component called envoy proxy, or here we can see in proxy. And there is a control component that is the server side of this, which is having STOD. So STOD comprises three other components. We will discuss them individually. So traffic from outside comes from this ingest traffic, and these proxies handle this. And for traffic management, this envoy proxy send request to the STOD that is present in the control plane, and it provide with the response to where to route them, and accordingly. So let's discuss the architecture. So there are two major parts, that is data plane and control plane. So data plane, it includes the envoy proxy deployed as a sidecar to the service. It provides this the feature like load balancing, traffic routing, and telemetric collection. So it handles. It is actually that handle. It is the actual component that handles the traffic between the services, and the component that it comprises is called envoy proxy. In the control plane part, so control plane basically manages and configures the proxy to route traffic. So which service to route traffic, it is decided by the control plane, and envoy just forward that execute that request. It includes STOD, which handles service discovery, configuration, and certificate management. So main component of the control planes are Pilot, Citadel, and Galleys. So we will discuss individual component in the next slides. So what is Envoy? Envoy is basically high performance proxy that is deployed as a sidecar to each pod. So it handles all inbound and outbound traffic for the services into the service mesh. And as I said, it is deployed as a sidecar inside a Kubernetes pod. The key functionality for Envoy is to traffic control. So it fine-grained routing of our HTTP, GRCP, WebSocket, and TCP traffics. It provides us with the network resilience, so we can control how many retries, failover, and circuit breakers, and we can also inject fault in our services for the testing purposes. In security, it enforces security policies, access control, and rate limiting. So, so it provides with the RBAC control and those kind of features. In extension, WebAssembly-based custom policy enforcement and telemetry generation. So it generates the telemetry for which we can have the better using Prometheus and Grafana. We can get the telemetry data and the matrices for better visualization and observability. Next is Pilot. So this is the component of control plane. Envoy was the component of data plane. So Pilot manages the life cycle of a proxy instance, and it handles responsibilities like service discovery. So it identifies and tracks the services within the mesh, and traffic management. Traffic management basically configures the routing rules and the load balancing for the services. So it decides where to route traffic and how to load balance the incoming traffic. And configuration distribution. So basically, it distributes the configuration between envoy proxy that is deployed on the various pods. Next is Citadel. So Citadel is Istio's security component that handles certificate management. So basically, it is a part that issue, rotates, revoke, basically manage the certificate for the secure communication. Authentication, basically it enables the mutual TLS that is called, in short, it is called MTLS. So for encryption and authentication for service to service communication. The other one is authorization. So it enforces role-based access policy to manage who can control what in within our service mesh, within our mesh. And next component is Galley. So Galley is basically responsible for configuration management within the Istio service mesh. So it validates our configuration. It also sometimes it also can generate and distribute our configuration. So configuration validation that is basically ensure that the configuration are correct and before they are applied. Configuration ingestion, basically gathering the configuration from various sources such as Kubernetes, and configuration distribution, in which it distributes the validated configuration to other Istio components like Pilot, so it can further get distributed within the proxy. So at last, first we started with this architecture diagram, but when we put all these components in place, we come up with this diagram. So basically, this is a whole Istio mesh architecture diagram. Our traffic comes in to our data plane through ingress, that is ingress traffic, and for our envoy proxy make a request for its management and routing to our control plane, that is our server side of the of this mesh. It's in the response to envoy, and through that request, through that response, envoy gets to know where to route, where to move in the mesh next. So key features, as we have discussed, the key features are the traffic management, security, and observability. So within the traffic management, we get better load balancing distribute. So it distributes traffic evenly across the services. Better traffic routing. So direct the traffic with the rule-based routing. We can inject some fault injection. So we can inject some failures within our mesh, within our services, to check the resilience of the services and the mesh. Traffic shifting. So we can gradually shift traffic from various versions of our application. So suppose there is one version currently working, and we want to move our or shift our traffic gradually within with some percentage to another version. We can do that in here. Within the security, it provides us with the mutual TLS. So encrypts the communication between the services, and it gives us role-based access control. So controls access control access based on role. It enforces the policy enforcement. So enforce the security policies within the mesh. And for observability, we can collect the performance data, track the request across the services, and record all the service logs. So so now we can discuss Istio use cases. After that, we will go to the demo. So for use cases, we can use Istio for canary deployment. So canary deployment is basically a technique to roll out new feature to a small subset of user before making it available for everyone. So basically, we can see in the diagram. So gradually we were having 100% traffic for one version of the service, but gradually we are decreasing from 80, 20, 50, 50, then 0, 100. So gradually we are moving from one version to another version if the users based on the user feedback. So Istio allows us to route a small percentage of traffic to a new version of services within the while the rest continues to use the old version. So this helps basically to this helps basically in the testing of new features in a controlled manner. We can perform A/B testing using Istio. So A/B testing is basically somewhat similar to the candidate deployment, but we are more getting this getting the final decision from the user perspective. So what we do, we provide two versions of our application, and this is a process of testing which version is performing better or much like within the users. So Istio can split the traffic between different versions of services based on this specified criteria, and enabling us. This can enable us gathering the performance data for and the user feedbacks. Mm, Other use case can be rate limiting. So controlling the number of requests a service can handle within a given time period. So we can control how much requests a service can handle, and this can enforce a rate limit to prevent overloading of our services and ensuring that our service remain responsive and available. Other use case is breaking. So it is a pattern to handle a failure gracefully. So by stopping the flow of requests to a failing services. So basically what we do, why it is called circuit breaking. So a closed circuit means a service is getting getting the request and it is resolving that request. But when the circuit get opens, that means when our service get down, the circuit breaking get open, and that means all the request that is coming to that service is now being queued, and that service is not able to provide process the request. So instead of what we do, we mark the flag of circuit breaking to open. So in this case, what it will do, it will simply reject those requests that is coming from other services to the failing service, and provide just simply say it will not wait for the processing. It will simply reject those requests. That's how we can decrease the size of the request being queued. And once the service is up and it start processing the request and giving the 200 response, then it go to half open state, and then again it become closed. So this is how we do. It's like a circuit breaking. So MCB, you can see a MCB for our Istio. So Istio can detect failures and read out the traffic to our healthy instances or provide fallback responses, improving the resilience of our application. So this is all the use cases. Now we can move to the demo. So let me just go to the demo. So yeah, basically this is the Istio homepage. For demo, what I am doing, I will just simply deploying a basic sample application in our minikube environment. So this is a minikube that I have started. I have also enabled the ingress so that we can communicate our with minikube from. We can provide some some request to our cluster application. So what I have done, I basically check the status. It was not running. Then I started with some memory and CPU configuration. Then I enable the ingress, and now you can see I have the components running. So first what we can do, we have to install the Istio. For installation, we can have here, we can come to here and we can use this download. So these links are provided in the presentation, in the PPT. You can use that from there. So basically we can copy this. Let me just open this side by side. So now we are downloading the binaries for Istio, and we will just let it download. Yeah, it's downloaded. Let's do LS. You can see here. Let's move to that Istio. Now we can add to our path, so we can add the path of this binary in our system path. So let's add that. Let's just copy that. Okay, let's check, is it running? By checking the version, we can Istio is not from cluster, but we have the CLI. So currently we have just downloaded the binary to install CTL. Install Istio CTL. We have to we have to type this command. Let me just get that command. Istio CTL install set demo profile. So what Istio is having? So Istio comes with some profile. So basically, we are here setting the profile to demo, but you can see there are multiple profiles. So first is default, then demo. Demo is basically for demo purposes. So we will deploy our book info app and there is minimal remote. You can check on this page what features are available with the different profiles. So first for now we are going with the demo profile. So let's just install that. So it will take some time. Till then I will grab the next command for verifying installation. So here in this page, this is in the Istio documentation. You can come and check the profile. So there is a demo and minimal one, default one. It is for production. It is a profile for recommended production deployment, and there is minimal one. Let's see. So what this command will do? This command will basically, you can see here there was two namespaces. Ingress engine, so it was due to that new minikube enable ingress command, and there was default cube system. So what this command will do? This command will create our ingress gateway, ingress egress gateway, egress gateway, and also install STOD. So once we check what component it deployed, let me just, so you can see there is another namespace Istio system. So it has three components: Istio D, Istio ingress, Istio egress. So these are deployed on our cluster. Now let's check the whether whether our installation was correct or not. So for that, Istio comes with a command called Istio verify install. So basically it will show us the component that Istio has installed. You can see some deployment services, config map, and the pod that are running, service account, role binding, role pod distribution, whether PDB, mutual configuration, and the other components. So these are the components that are deployed once you deploy the Istio. So let's clear this. Now move to now we can check this. Let's see what we have inside our Istio 1.2.3 folder. So you can see there is our library, there is our binary file. It comes with some sample. Istio comes with a sample application. So you can go and check that. So let's move to the sample one. And so this is a book info that we'll be deploying now. So let's go and deploy this one. So for that, I think let's first check what is inside that. So book info, platform, queue, and I think okay. Yeah. That's correct. So what is basically it is doing? It is so it is deploying services. So basically we'll be having. Let's go to this one again. So what is exactly it is deploying? So basically it will be deploying a product page. Then it will having a 3 version of this view, one with no star, other version 2 with black star, and version 3 with the red star. And it will also have a detail service that is deployed in Ruby, and then a rating service that is deployed on Node.js. So basically, it will be deploying those services. So you can check there is a deployment for detail version 1. Then there is a deployment for service and count, and then the deployment. Then for reviews should have 3 versions. So this uh, review version 1, then deployment review version 2, and version 3. Then we will have a production page deployment. So let's go and apply this one. Okay. So now these are deploying. Let's check. Go to that. Now you can see they are being created. So we discussed that in Istio we will get some sidecar containers. So that means one pod will have 2 containers. But you can see we are having only 0 by 1. That means our component is having only one container here. So for I'll just show you. Let it just complete. It will take some time. So basically, what is having? If you Istio comes with a Istio works basically with levels. So uh, um, before injecting anything, any sidecar container in our cluster, we have to set a level for that cluster to allow a sidecar injection. So I will just show you. Just let it deploy. It will take around 2 to 3 minutes. Some services are coming up. Just wait for. Only one container. So fill the product page come up. Let me give you some other command, that is stoctl analyze. So basically what it does, it analyze. So now, yeah, our cluster is up. So what this command basically do, it analyze our Istio cluster and check whether there is any configuration error or not. So let's just run that. So yeah, you can see the name. This namespace is not able for Istio injection, and it is suggesting a command to enable get this namespace a label for Istio injection, and then only it will inject our sidecar containers. So let's copy this one, this command, and try one. So for this, so we have labeled our namespace. You can check. Okay, describe namespace default. So you can see this this namespace has a label now. For now, we have to redeploy this. So just let me just redeploy this one. Platform you looking for YAML. So we have remove our container. Let's redeploy them. It will not take some much time then now because image is normal local, so it should happen quickly. Yeah. So let's check the pods. Yeah, you can see 2 out of 1 is running, and now you can see 2 out of 2. Let's describe some pod. Let's go and get. Let's describe pod product page. So here you can see a init. Let me scroll up. So here you can see a init container. So init container is basically a component of container that it starts and terminates. So you can see the status that it's terminated, and 2 other containers. One is for product page. So this is our basically application. It is the image for our application, image address, and there is another component called Istio proxy. So this is a sidecar proxy that we discussed in the architecture. So this will handle our request. So now you can now let's and check another component. So let's visualize our this with her visualization tool called Kyali. So for that we have to apply some other component from your simplifies. Let's do that. So add-on directory. So we'll apply this whole add-on directory. So it will have components for like Kali, Jaggery, Prometheus, Grafana. So I'm applying all. See, so these are creating. This is creating service account. You can see some Jaggery component and Kali. So yeah, let's check all. Okay, so these all get applied in the Istio system only clusters. Some of the containers are still creating. Let's wait for them. I think Kali is still creating. Just wait till it get active. Let's check again. Okay, they're still in creating mode. Yeah, it has been created. So to bring the dashboard, just we have to do Istio CTL dashboard Kali. So what it does is basically open a localhost and okay. So it is having some component. I think it is due to some undeployed component. Let's wait. Prometheus is still running, so it will getting the metric from Prometheus. So we have to wait for till it get deployed. Okay, it's deployed. Now let's bring back this dashboard. Yeah. So in this dashboard, so it is a very you can see interactive dashboard, and you can see the traffic, how the traffics are going. You can see all the services here, all the application. So we are having four application services, yeah, four application parts, four services, five services. For details, Kubernetes, one is the Kubernetes. You can also see the graph. So for graph, we just display the ideal nodes here. So this is the graph. So let's put some traffic on this application, and we'll check how they behave, how it is coming. So, and here you can also see the Istio configuration. We haven't applied any Istio configuration yet. We'll be applying soon. So let's go in the terminal and apply the Istio component. So let it run there. Now just I will go to this plus cat. Yeah. So this is a gateway. So what we'll do, we'll deploy two components of Istio, that is a gateway and a virtual service. So gateway is basically a component that allows ingress traffic to come to our Istio cluster. And virtual service is like basically a set of rules that that routes our request to the specified specified services. So you can see there are two components. One is gateway. Basically, it is allowing our allowing all the hosts, and here is the destination. So we are pointing our request to the product page. So let's apply this. So let's check for the gateway. Okay, gateway is running now for the virtual service. So virtual service is running. So now we have to get the IP for our in Minikube, so that we can. So this is the IP, and we have to also get the port. For the port, I will just simply get this service name, this command, and it will give us the port. So port is 23. So let's create the request. So in place of host, we can just put our IP 192.168.49.2, and in case of port, we just put our port number. So basically, this is a while loop. So it runs every 0.01 second, and it basically sends a request to this page, and send a response and direct that output to DevNam. So just run this. So now we can you can see some requests will be coming to our Kali dashboard. It will take some time. Yeah, you can see this one. Yeah. So you can see some requests are coming to our application, and you can come here, and you have very, you can say, well visualized dashboard here. You can also see the traffic animation. So you can see requests are coming from here. and it is going to, and you can also see the loads, traffic distributions. Let's that, yeah. So it is being distributed to the various services. Okay. Yeah. So there are many other features that you can do here. Let me just stop the request, and also, yeah, let me stop this dashboard. So there are various things you can do with this one. This dashboard is very interactive. I will suggest you to do the self dive in this one. It's the most popular service mesh that is available, and it is quite interesting to get your hands dirty. And you have any, so if you have any questions regarding that, you can come up with that. Yeah. Any questions? So here is the reference page. So you can go here and try yourself. These are some blogs that I refer to. Okay. In case no question, then thank you everyone. Yeah, Himanshu.
So as asked by Amir, so guys, if you're having any queries, I guess this is the right moment to get them answered by Amir itself. If no, then you can surely reach out to him later on Teams, and I guess he'll be happy to answer your queries later.
Yeah, sure.